So welcome back students. Up to now we learned that what is the statement of multiplication theorem, okay, and one deduction we had sent based upon multiplication theorem. So multiplication theorem here we have proposed without any proof at all because it is not in your syllabus, okay. So now there are two more theorems, okay, based upon multiplication theorem itself, right? Even those two theorems we have to study without any proof at all, but simple logic we must have to learn here so that we may be able to keep the concept of these two theorems in our mind. Okay, so now our next theorem is total probability theorem. So according to the statement of this theorem, we have A1, A2, A3 dash dash A and B the mutually exclusive and exhaustive events of a random experiment of which S be the sample space where probability of AI is greater than 0 and I belongs to the set containing elements 1, 2, 3 dash dash n. So it means to say that any event among A1, A2, A3 dash dash a and b may take, doesn't matter. For all of them, our probability is greater than 0. Okay, probability is greater than 0. It means that this statement is saying what? That it will not hold if we will consider impossible event. Okay, because for a random experiment, even impossible event is possible. Okay, and sure event is also possible. So this statement holds when our events of the random experiment may not be impossible event. So if these events of the same random experiment will not be impossible events, then obviously probability of those events must be greater than 0. Okay, so this thing is obvious. Okay, let A be an event of the same random experiment. Okay, not necessarily one among A1, A2, A3 dash dash an. Okay, now we are going to take one more event of the same random experiment, and that event is not necessarily among one of A1, A2, A3 dash dash an. Okay, it may be among one of them, or it may not be. Okay, then probability of A is equal to probability of A1 into probability of A slash A1 plus probability of A2 into probability of A slash A2 plus probability of A3 into probability of A slash A3 plus probability of A plus dash dash plus probability of AN into probability of A slash AN. Okay, and this is equal to, we can also write it as sigma of PAI into probability of A slash AI, where I varies from 1 to n. So this is the precise notation or representation of this statement. Okay, what we are writing at this place. Now, this is the statement of total probability theorem. So here proof of this theorem is exempted. Okay. Now here this thing is necessary to understand that what is the meaning of mutually exclusive and exhaustive events. You people have already studied about this thing at class 11, that what is the meaning of mutually exclusive and exhaustive events. But even at this time I want to recall that what is the meaning of mutually exclusive and exhaustive events. Okay, so here A1, A2, A3 dash dash AN are mutually exclusive and exhaustive events. Okay, so it means that our AI intersection AJ is equal to 5. Okay, is not equal to 5. This thing we should have to write. Is not equal to 5. Right? So AI intersection AJ is equal to, I'm sorry, this thing should be equal to 5 itself. Okay, means to say that there should not be any common element at all. Right? And secondly, so this stands for what? That these are mutually exclusive events, right? And secondly, A1 union A2 union A3 union dash dash union AN, and this is equal to S. So this statement is showing that the system of events A1, A2 dash A3 dash dash AN is exhaustive. Exhaustive stands for it is covering the whole system, okay, in the form of sample space, right? that is union of ai where I varies from 1 to n and this is equal to s. So if we consider its probability, then that will be equal to what? That will be equal to 1 always. Even at this place, I tried to explain you that what is the meaning of mutually exclusive and exhaustive events. Okay, as we are considering a system of n number of events which are mutually exclusive and exhaustive, then how can we represent like that? You can see here S is a complete system, okay, which has been divided into n number of events, and this n number of events don't have any common element at all. Okay, so this thing is showing like that. Here this S has been divided into n number of events, and all of this n number of events are exclusive. It is not containing any common element at all. Okay. So I hope that you people have understood that what is the meaning of mutually exclusive and exhaustive events. One more thing I want to show you regarding total probability theorem, and that is what? That actually in total probability theorem, our probability of A is equal to, here it is, probability of A intersection A1, isn't it, union A intersection A2, okay, union A intersection A3, union dash dash union A intersection AN. It is like that. It is like that. Okay, and here you will compare any two events occupying within a pair of braces or parentheses. Okay, then those are disjoint. Those are disjoint. Due to this reason, here just after this statement, we have written this statement. Okay, in the sum form. Okay, in the sum form. Because you know well that probability of A union B, that is equal to probability of A plus probability of B minus probability of A intersection B. This thing you know well. Okay. Now, if A intersection B will be equal to 5, then probability of A intersection B will be equal to what? That is equal to 0. So that probability of A union B, that will be equal to probability of A plus probability of B. Isn't it? So, even there is the same thing at this place. Here, we have already stated that A1, A2, A3 dash dash AN. So, these are the system of, these are forming a system of mutually exclusive and exhaustive events, so that you will consider the union of each one of those events with, intersection of each of those events, okay, and all of them will be united to each other. Then even in this case, each of these events will be considered as the mutually exclusive events, okay, and then if it will be expanded, then after that we can obtain this result. And this result what we are getting here by the application of multiplication theorem. So thank you.